So in this class we will discuss another problem on linear programming using graphical method. So it's a civil engineering application problem. A contractor is planning a job that will require a large amount of gravel and sand. There are two pits, A and B, from which he can obtain material and plans to haul, that means move from these pits. The material composition and the minimum requirement is given in the table. It costs rupees 1000 per meter cube for material and handling from pit A and rupees 1500 per meter cube from pit B. Formulate the linear programming problem and determine the blend which results in minimum cost. So that means it is a minimization problem. He has given in a table the data like this. So the materials are listed here. In PTA, the composition is like this: coarse sand 20%, fine gravel, coarse gravel 20%, fine gravel 15%, fine sand 25%, coarse sand 40%. In pit P, these are the values, and minimum requirement is this. Of course, in the last, it doesn't require this coarse sand part. So that is why it is given as nil. So there is no constraint for this coarse sand, but there are constraints for these three types of materials. So since it is a problem of minimization of the cost, so let us formulate the problem like this: minimize Z. So Z is the cost. So we have to minimize this cost. In the last problem I have taken profit. So it is a maximization problem. This is a minimization problem, cost. Now we have to find out how much we have to take from pit A and how much we have to take from pit B. So let us take X as, X is the composition which we have to take from pit A, and Y is the composition which we have to take from pit B. Or we can say how much meter cube has to be taken from the pit A and how much meter cube has to be taken from pit B. So since for 1 meter cube the cost is 1000 per meter cube if you want from pit A. So let me take, this is the X as the volume from pit A and Y is the volume from pit B, which has to be lifted or hauled to have minimum cost. So for 1 meter cube from pit A, it costs 1000 rupees. Therefore, for X it becomes 1000 into X. Then plus for 1 meter cube from pit B, it costs 1500 and into Y. Y is the volume that is required from pit B. So this is the objective function now. Minimization Z is equal to 1000x plus 1500y subjected to. Now we have to develop the constraints now. He has given in this table the constraints. So the constraint for coarse gravel will be 20% of X plus 30% of Y should be greater than or equal to 2000, because this is the minimum requirement. Minimum requirement is 2000, therefore it should be greater. So the equation of 20% means it is 0.2 times X plus 30% means 0.3 times Y should be greater than or equal to 2000. This is first constraint. Second constraint corresponds to fine gravel. 15% means 0.15 times X plus 0.4 times Y should be greater than or equal to 3000. Third constraint is this: 0.25 for the fine sand, 0.425 times X plus 0.2 times Y should be greater than or equal to 2000. Only 3 constraints you can have. The fourth, since there is no requirement of coarse sand for the project, so this doesn't have any constraint. So there is no constraint for this because the material is not required for the particular project. So This is the formulation of the linear programming problem now. Minimize z is equal to 1000x plus 1500y subjected to these conditions. Now we have to find out the values of x and y, thereby we can find the value of minimum value of that z. So as usual we will solve this problem by graphical method. So you have to plot the straight lines of these three inequalities by converting into equality. Now let us convert these three constraints to equality form. So equality form, the first equation becomes 0.2x plus 0.3y is equal to 2000. So let us put x is equal to 0, corresponding value of y will be 2000 divided by 0.3. So 2000 divided by 0.3, so it will be 6666.67. Then y, if you put y is equal to 0, x value will be 2000 divided by 0.2. So 2000 divided by 0.2, which is 10,000. So the points are now 0, 6666.67 and 10,000, 0. So that is they are the points for the first straight line. So this is the first straight line. Similarly, the second straight line is 0.15x plus 0.4y is equal to 3000. Second equation. Here let us put x is equal to 0. Y becomes 3000 divided by 0.4, which is 7500. If you put y is equal to 0, x becomes 3000 divided by 0.15, which is 20,000. Now the corresponding points will be 0, 7500 and 20,000, 0. Now the third equation is this 0.25x, third constraint, plus 0.2y is equal to 2000. Equation 3, if you put x is equal to 0, y becomes 2000 divided by 0.2, so which is 10,000. If you put y is equal to 0, x will be 2000 divided by 0.25. 2000 divided by 0.25, which is 8000. Now the corresponding points will be 0, 10,000 and 8000, 0. Now we have to plot these three straight lines in a graph sheet, plain graph sheet, by choosing suitable scale. Then we have to find the visible region, and we have to find the values of z at the corner points of that visible region or the visible boundary. Then among the values, whichever is least value of z, so though that value will be the final answer. Now we will plot a graph on a graph sheet by choosing suitable scale. You can choose suitable scale here. So the values are in thousands. So therefore you can have 1 centimeter is equal to some 2000. You can have both on x and y axis. Now let us plot the values now. For the first straight line, x is 0, y is this much. So I will take x is 0, y is I will take here 6000, 0, this is 0, 6666.67. This is one point. The second point this is 10,000, 0. So 10,000 will come somewhere here. So 10,000, 0 on x-axis. So we have to join these 2 points. So okay, we will take this point. We have to join these 2 points. So by a straight line. So this gives the equation Then the second equation, x is 0, y is 7500. 7500 will come somewhere here. So 0, 7500. And another point is 20,000, 0. 20,000 will come somewhere here. So choose suitable scale, 0. Now we have to join these two. If you join these 2 points by a straight line, this gives equation 2 line. Then equation 3, x is 0, y is 10,000. So 10,000 will come somewhere here. So 0, 10,000 is 1 point. Another point is 8,000, 0. 8,000 will come somewhere here. So 8,000, 0. So join these 2 points by a straight line, it gives equation 3. Yes. Now, here if you observe, all these 3 constraints are greater than or equal to, because he has given the minimum requirement. This is minimum requirement. So all the values are greater than or equal to that. So greater than means the feasible region will be above these 3 lines. Above the 3 lines, you will have the feasible line. Now let us see which is the feasible boundary, feasible region. See here, it is coming like this. So if you take this, all the inequalities are greater than or equal to. Since they are greater than or equal to, so these 3 region becomes the feasible region. So the region should be greater than or equal to means it should be above all the 3 lines. So this region is the feasible region. Wherever it cuts, so this becomes the feasible boundary or region. So you can just have the points, boundary points, and then look at those boundary points. One point is this A, another point is this B, another point is this one only. See, only 3 points. A, B, C. Of course, at A and C we have the values of x and y. At A x is 0, y is 10,000. At C x is 20,000 and y is 0. Only we have to find the values of x and y at B. So from the graph, if you take the coordinates of B, it is 2,875. So x is this, you get 2,875, and y value is 6,400. 6,400. See, after drawing the graph, you can locate the points here. So the boundary points are A, B, C here. Since all the constraints are greater than or equal to, so that the feasible region will be above those 3 lines. If it is minimization problem, we have to take below the lines. If it is maximum, if it is less than or equal to, then we have to take below the lines. Since it is greater than or equal to here, we have to take above the line. So now we have to get the values of this z at these 3 points. So at A, at point A, the value of z is, so z is given as 1000x plus 1500y. So 1000 into x value at point A. X value at point A is 0. So 1000 into 0 plus 1500 into y value is here 10,000. So the value now becomes 10,000 into 1,500. So 10,000 into 1,500 means it comes to 15 followed by 6 zeros. So this is the answer. Okay. Then at point B, z is equal to 10,000 into x value here is 2875 plus y value is 1500 into y value is 6400. So here you will get 1000 into 2875 plus 1500 into 6400. So it comes to 12475. 12475 000 rupees. Next, at point C, the value of Z cost is x is 20,000, y is 0. So 1000 into 20,000. Sorry, 1000 into 20,000 plus 1500 into 0. Y is 0 there. So it comes to 2 followed by 7 zeros. Rupees. So among these three values of Z, so the minimum value is this. So 1,24,75,000 rupees. So this is the minimum. So because we are interested in minimum value of Z, so this is the minimum cost, and the corresponding values of X and Y. X and Y, they give the requirement. So we have to we have to take 2,875 meter cube from pit A and 6,400 meter cube from pit B to have the minimum cost of this much. So that is the solution by graphical method. So you can have maximization problem or minimization problem. So both I have solved here. So in the maximization problem, so the constraints, if they are less than or equal to, then the physical region will be below all the constraint straight lines. In the minimization problem, if the constraints are greater than or equal to, then the physical region will be above the constraint lines.